Now, if you do the math and ask how much mass is there within the radius of the known universe, and see how that compares to a black hole's mass and size, it turns out the entire universe can be analogized to being a black hole unto itself, with a horizon beyond which you cannot see.
Wow.
So it is not completely crazy to think of the universe and all that's going on within it as containing a black hole that has all the external properties that any black hole we're looking at would have within us, within our universe.
Okay.
So then you ask, if we are a black hole, are we a black hole in some larger universe?
That's what I was about to say. So who's to say that there's not more universes with the same black hole that we would be?
Correct. This is what led to the idea that maybe black holes are portals to entire other space-time continuum. So in Men in Black, the galaxy on the belt of Orion,
right.
If it were a black hole on the belt of Orion, then that would legitimately be an entire other universe. But that's not as scientifically realistic as there being a black hole on the belt. And then you go into the black hole, there's a whole universe. Okay, so if you have such a particle, what would happen to it? Well, it would live backwards in time. And we call this particle tachyons. Now, tachyons are really cool if you think about it, because if I sent it to you now, you would have gotten it before I sent it. So on the other side of the speed of light,
yes,
it would take an infinite amount of energy to slow them down to the speed of light. So so if you want to take Einstein's equations and flip them to the other side, knowing you can't pass through the speed of light, these are the properties of what's going on. So a black hole can essentially evaporate very slowly, particle by particle, evaporate by this phenomenon, so that it can lose mass through its energy field, because mass and energy are one and the same.